Okay, so the last thing that we're going to talk about today is how to describe a scatter plot in terms of the strength. And so, obviously it's going to be how strong something is. So strength is how strong the relationship is between those two variables. How much are they affecting each other, in other words, okay? Because remember, that's what we're looking at, is how much are they related, okay? And so to figure out the strength, you have to actually figure that out by looking at the correlation coefficient, okay? And so it's determined by the correlation coefficient. And the letter that they use for correlation coefficient is R, okay? So what is it? Well, it's going to tell you how strong the relationship is between those two variables, those two things that you're looking at, how strongly they're related. And it's going to tell you actually two things. It's going to tell you the direction of it, which we talked about in the last video. That tells you whether it's positive, negative, or if it'll be zero. In other words, there's no correlation. Okay, so remember in the other video, positive correlation went up, negative correlation went down in the scatter plot, and then the zero correlation is the one that was kind of all over the place, okay? So that's one thing that it actually tells you, but it also, and this is kind of the biggie with correlation coefficient, is it's going to tell you how close that data fits a line, okay? So in the last slide, you would have noticed and talked about a little bit what's called the line of best fit, and they also call that the least squares regression line. I know it's a mouthful, but the name of that has to do with how you find that line, which is in a statistics class. So right now we're going to have our calculator find it for us, okay? But this right here will tell how close, when you graph the data, so like if I had my scatter plot and it looked like this, it's going to tell how close overall, kind of on average, these points come to actually forming a line, okay? And so if I drew my line of best fit through this, it would go kind of through the middle of those points, and I'll do the best I can at drawing a line that goes to the middle of them. So if I drew and found the equation of my line and graphed it, it would look something like that, okay? So the line of best fit, or what they call the regression line, should go kind of through the middle of your points, okay? And so the reason why it's important to kind of have this line, and the reason why the correlation coefficient is important to know, is because they use this and the line to make predictions. And so if your points, when you graph them, actually form a line, then that means that you can make really good predictions off of that, versus if your dots or your points, when you graph them, are a little further away, then your line may not be as reliable to use to make predictions. And so they use these two concepts in statistics when they are trying to predict things, depending on what you're looking at, okay? And so like if you think back to that first video that I had, I was looking at shoe size and somebody's height, and I was trying to figure out, if I know somebody's shoe size, could I tell their height? And so if I graph my scatter point and it exactly formed a line, then that's a good indicator that I could probably make a really good prediction if I find the line that goes through those points, okay? So that's where this comes from, all right? So back to correlation coefficient. I told you it's going to tell you two things. It's going to tell you the direction, and it's going to tell you how close these dots come to forming or fitting a line, okay? So how does it do that? Well, it's going to give you a number. So whenever you find correlation coefficient on your calculator, it's going to tell you R equals something, okay? And so that number, it's going to be a number, is going to range anywhere from -1 to 1, all right? If you graph your coordinates and they actually form a line, so for instance, if I graph it and my points actually line up to where if I drew a line of best fit, it goes through them perfectly. So if that happens, then the correlation coefficient, that R, will either be exactly -1 or 1. As to which one, it depends on the direction. Okay, so if, for instance, you graphed it and it formed a line just like those dots did, the R, the correlation coefficient, would actually be -1 for that one. Okay, well then what does that mean? That meant, well, the negative told me that it had a negative correlation. So whatever sign the correlation coefficient has will be, will tell you the direction of it. That's how you know the direction, okay? And then you could also have seen that from my graph. But it's going to tell you how strong it is. So the closer this number is to either -1 or 1, if it went up instead, the stronger those, or the closer those points are to actually forming a line, okay? So notice in this one, when I graphed my scatter point, it actually formed a line. So that's why the correlation coefficient would be -1, okay? Well, the other side of that, so that's if they actually form a line. So -1 would be they form a line going down that direction, okay? Well then, what would the graph look like for the correlation coefficient to be exactly 1? Well, if you graphed them and the points actually formed a line that went up, that would have a correlation of exactly 1, okay? So the thing you kind of need to know is it could go either way, all right? It's either going to go towards -1 or 1, okay? And the sign, remember, it tells you the direction that it goes. So if you start going back towards 0, these are the graphs where the points start getting a little further spread out from your line, okay? And then if the correlation coefficient was actually 0, these are the graphs where there's no correlation. So these would be the graphs that have no relationship to each other. They are those two topics, those two variables are not related in any way, okay? So that would be kind of what your graph looks like. And there are a couple other ways that your graph could look. If the correlation coefficient was 0, another way that it could look, and I'll just write this down because I didn't talk about it in the other video, is if you graph them and it forms like kind of like a vertical line going up and down, that would be a correlation coefficient of 0 because one's not technically affecting the other if it looks like that. And then the other one would be if you graph it and it kind of forms a horizontal line. So I hope you guys can see this. So if it forms a horizontal line when you graph your points, then the correlation coefficient would be 0 there too, okay? So correlation coefficient the closer the points are to the line, and if it goes down, it's going to be closer to -1. The more they form a line in a positive direction, the closer it's going to be to +1, okay? So now let's talk about the middle stuff, all right? When you start having the coordinates or the points a little bit further out, the correlation coefficient is going to be somewhere in between these two numbers. So for instance, if you graph your data and it's got a positive trend to it, so it goes up, but the dots are a little bit further away from making a line, kind of like that, then that's not going to be a perfect graph. It's not going to be a perfect line, or it's not going to fit exactly with the line when you graph your line of best fit. So if it looks like this, it's going to be a number somewhere between it. So like if they were a little further apart, then this might have a correlation coefficient of like 0.5, okay? If they were really, really, really close to forming a line, but they weren't a perfect line, so kind of like this, where there's most of them are kind of forming a line, then it might have a correlation coefficient closer to like 0.9 or 0.8, okay? And same thing on this side, if you graph it and it goes down, it has a negative correlation, but the dots don't perfectly form a line. then that means that it's going to have a correlation coefficient somewhere between 0 and -1, okay? So that's kind of how the correlation coefficient works. So the main idea here is the closer the points are to the line, the closer they come to actually forming a line, the closer the correlation coefficient will be to -1 or 1, okay? And then the more it looks like this or this or this, the closer it'll be to 0, okay? Now describing it, all right? Remember, you can describe it with a direction and you can describe it based on the correlation coefficient. So how do you actually describe it? Well, if you find the correlation coefficient and it's really, really close to 1, like 0.95, 0.99, 0.98, or even 1, then you would say that it has, or those two variables have a strong, and if it goes up, you would say it has a strong positive correlation, okay? If you graph it and the points aren't perfectly aligned, like maybe kind of like this graph, maybe the correlation coefficient is like maybe it's between somewhere here and here, you would say it has like maybe a moderate positive correlation. If it was somewhere from 0.5 closer to 0, that would be more of like a weak correlation coefficient. So we could put little things. This would be a moderate positive correlation. If it was kind of somewhere in here closer to 0, you would say it has a weak positive correlation. If it was 0, then it has no correlation. So make sure you say that. And then kind of the same thing the other way. If you graph it and actually forms a line going down, then you would say it has a strong negative, because it goes down, negative correlation. And then kind of like the same, like I did on the other side, the closer you get this way, the weaker the correlation will be between them. And remember, correlation is how they're related. So they wouldn't be as closely related. One may not affect the other as much. So if, for instance, you find it and it's like a 0.75 or a 0.8, or actually 0.8 would be getting a little bit closer to strong. So if it was like 0.75 to 0.7 or something like that, you would say it's a moderate, and this side's the negative, so you'd say it's a moderate negative correlation. If it was somewhere between like 0.5 and 0, you would say it has a weak correlation. They're weakly related to each other, okay? And so I'm going to put a visualization up in the next slide, but hopefully that kind of helps to understand how to talk about them.